standard and autopilot cluster. So what I'm going to do is I'm going to delete my autopilot cluster and just work with the standard cluster, because the standard cluster is a more complex one. So if you understand that, you will understand the autopilot as well, right? Okay, so let's just delete the autopilot cluster. And so now I'm going to, so now I've got a cluster, and this is a standard cluster, and I've got 3 nodes, right? And normally when you manage a Kubernetes cluster, you can do it from the command line. But to do that, you've got to connect to the cluster and authenticate to it. So let's do that. We'll connect to the cluster. So you'll see they're bringing up this command here, which authenticates my Cloud Shell session to the cluster. So I'll run that session. I'll run that command, sorry, in Cloud Shell. Okay, so I can run this command. And once I authorize that command, I'll just start up Cloud Shell in a different tab. And so now I can interact with my cluster using kubectl commands, right? So kubectl is the command line utility for interacting with Kubernetes clusters, right? So now all I've done there is just displayed all my nodes, right? Now, if I go, I can also manage my Kubernetes objects from the cluster as well, from the console as well. So you'll see if I go, so I've just got my 1 cluster now because I'm deleting the autopilot cluster. And if I go and have a look at workloads, you'll see at the moment I've got no workloads deployed to my cluster, right? So what we're going to do is we're going to deploy a workload. So normally when you deploy a workload, you would do that through the kubectl commands, and you would have YAML files that define the Kubernetes objects that you want. But just for demo purposes, I'm going to use the console here, right? So again, I'm going to create a simple deployment, and that deployment is going to be running the Nginx application on Kubernetes, right? So basically remember, a Kubernetes workload is always a container image. So I'm going to run the Nginx container as a Kubernetes workload called a deployment, right? Now, as I say, normally when I do this, I would specify the YAML and define it with kubectl, but I can view the YAML here. And again, I'll just, choose the right cluster. And you'll see that's the YAML that gets generated automatically. Now, probably the most important thing when you're creating a Kubernetes object is the type of object you're creating, which is a deployment. The number of replicas of the container image you are deploying. So in my case, I'm deploying 3, and also the name of the container image that you're deploying. So I'm deploying the latest version of Nginx, right? So let's go ahead and deploy that workload. Now, while I'm doing that, if I do kubectl get pod, you see it's already starting to deploy, right? So when Kubernetes runs a container, he doesn't run it directly. He puts the container in a Kubernetes object called a pod, right? So if we just have a look at some of our notes here. So basically a GKE cluster is made up of nodes. And basically nodes nodes can run pods, and pods or containers run in pods, right? And the other one there is that workloads so the type of workload that we created was a deployment, right? And also services allow me to connect to workloads. And again, this is sometimes called exposing the workload, right? Okay, so we'll go. So you'll see now if I go back into the console. So now I've got a workload, and I've got that workload called Nginx, and that's of a type deployment. So a deployment is a type of Kubernetes object, right? And again, it has 3 pods. So it has 3 copies of the Nginx container running, right? So if we go and have a look at the details of that deployment, you'll see here I have under manage pods, I've got 3 different pods, right? So each pod has a copy of the container image running inside it, right? So if I select one of those pods, and you can see that basically this is the name of the pod, but you'll see that within the pod, I have this container running inside it, right? So basically a container image runs inside a pod, right? And a pod and nodes run pods, or pods run on nodes, right? Maybe I'll stick to the same tense, otherwise you'll get confused, right? So basically pods run on nodes, right? So a cluster is made up of nodes, workloads are made up of pods, pods run on nodes, containers run in pods, and services, which I haven't showed you yet, allow me to connect to the workload, right? So that's just kind of a summary of the Kubernetes objects that we are talking about. Right? So again, if anyone's interested in, I can put that in the chat. So let's create a service, right? So again, if I go back to my console, so you see here at the moment, I don't have any services created for my cluster. And in fact, same if I do the command here, I don't have, well, I've got one service, but that's system defined, right? But I don't have anything that enables me to connect to Nginx, right? And notice that if I do kubectl get pods again, so you see now the pods, they work just creating the container image, but now they're in a running state. So this basically means that the application is running successfully. Okay, so now I'm going to expose the application so I can connect to it from outside the cluster, right? So to do that, I need a service object, right? Otherwise, I'm unable to connect to the containers running inside the pods to connect via a service object, right? So let's create that service object, and well, we can do it directly from the workload. So let's just do it here. So you see if I choose that workload, and then I can expose that workload, which basically will create a service object. And that service object will listen on port 80. And there's different types of service objects depending on whether I'm connecting from inside or outside the cluster. But I want to connect from outside the cluster, so I'll create the service of type load balancer. Right? And that will become an endpoint that I can connect my application to. that I can connect to my application through, right? So again, if we look at services, we'll probably see that Nginx one just in the process of being created, right? So you see it's still pending the assignment of an external IP address, because if I'm going to connect from outside a cluster, I need an external IP address, right? So, okay, so you see now it's got an external IP address. So if I copy that external IP address, sometimes it takes a little bit longer, but anyway, let's just try, see if it's available yet. It might take a little bit longer to fully initialize, but let's see. Okay, so now it is initialized. So you'll see now I've connected to that service object, and that service object has passed my request through to one of the pods running the Nginx container, right? Now, of course, as a user, I don't know which pod serviced my request, because remember, I've got 3 of them, right? So again, if I go back and look at the workload, I've got 3 Nginx pods. So they're all running the same container image, but that's just for redundancy. If one of the pods fails, Kubernetes will automatically restart it, right? Now, again, I can kind of show you that if I go in here. And so you see at the moment I've got 3 pods, and let's say I want to delete one. You'll see that, in fact, it'll probably happen so quickly you won't be able to see it at all. But basically, if I delete that pod and then do get pods, you can see already it already restarted a replacement pod, right? Because you see I deleted that BZ5MH one, that top one. So you see that has been replaced by this one here, this F92S8 one. How do I know? Because look at the age of the pods, right? So you can see that when I deleted the pod, almost immediately Kubernetes replaced that deleted pod with another pod, right? So that is sometimes described as the self-healing or auto-healing capabilities of Kubernetes, right? That makes Kubernetes workloads more robust. Okay, so I'll just pause there, and if there are any questions about what we've seen so far. How do you find out which pod is running on which node? Well, you can do that from the command line. So you can see that these are the pods here, and these are the nodes that they're running on, right? So you see this command will show you the nodes that they're running on. And you can see that actually they're spread, they just happen to be spread across all 3 nodes, right? And again, you'll notice that I didn't tell Kubernetes to do that. He just kind of figured that out himself, right? Now, let's see if we delete this one, the newest one. I want to see whether it creates the replacement one on the same node, right? Again, it may or it may not, right? So if we delete that one, and then I rerun the command. Okay, so you see, in fact, it did replace this one here, right? So this one here is only 8 seconds old. So it did actually replace it on that node. So it's quite smart in how it spreads the pod across the nodes. Sorry, I don't understand the question. If we deleted the port, how to replace the pods? I don't understand what you mean by deleted the port. So you have to elaborate on that question. Okay, so let's look at the slides then, and I think we can. So basically, the first slides are just talking about what containers are. So containers are just a way to isolate applications. And you kind of have to understand the problem containers were solving, right? Because in the old days, the only way you could isolate an application was run it in its own virtual machine. But with containers, you can run it in its own container, and that will be separate from other containers and other apps, right? So containers is a more efficient way to isolate apps. And containers can be run in Google Cloud. They're either run on GKE or Cloud Run. I mean, theoretically, they can be run on Compute Engine, but it's not very common. They can also be run on App Engine Flexible, right? There's two versions of App Engine Standard and App Engine Flex, but the two main container platforms are Cloud Run and GKE. So clearly we're talking about GKE here. But the container images themselves are built with Docker tools, right? So, you know, Kubernetes always runs containerized applications, right? So if you're going to get an application into a container, you've got to have a Docker file. So think of a Docker file as the instructions on how to build a container image, right? So think of it as like a make file for containers. Then once you've built the container, then you can run it. So in this example here, we're just running the container image locally on maybe on our developer instance, but we're not running it in Kubernetes, right? So Docker is used to build the containers, but it's not really a sophisticated runtime environment like Kubernetes or even Cloud Run, right? So typically what we do is once we've built the container locally and tested it to make sure it runs okay, then we push the container image into artifact registry, right? So that's what they're doing here with the Docker push command, because we can't deploy it into Cloud Run or Kubernetes engine unless it's in artifact registry or container registry. So the developer builds a container image locally, tests it locally, pushes it into artifact registry, and from there we can deploy it into GKE or Cloud Run, right? Okay, so artifact registry is a tool for storing container images as well as other software artifacts as well. Okay, and it can also store npm files, yum files, so basically it can store different types of software artifacts. But from Kubernetes point of view, the main thing we're interested in is that it can store Docker images, right? And again, remember, artifact registry is the new and improved version of container registry. Okay, so now we're going to talk about GKE, which we've already talked about. So basically, we've talked about how containers allow us to isolate applications. So think of Kubernetes as a runtime environment for running containerized applications, right? Now, we also need to distinguish between Kubernetes, the open source project, and Google Kubernetes Engine, or GKE, which is the managed Kubernetes service in Google Cloud, right? So Kubernetes itself is an open source project. It was developed by Google and then open sourced, right? And in fact, it was based on a proprietary Google technology that Google had called Borg, but that wasn't really feasible to open source. So they open sourced Kubernetes instead, right? So Kubernetes, today you can run Kubernetes applications in Google Cloud, in AWS, Azure, Alibaba, and also on-prem as well, right? So it's a very widely supported language, right? Which platform is used by Kubernetes? Well, I think it's Docker and container, the containeri, right? But certainly Docker and containeri formats are supported, right? Okay, so it's been a very successful open source project, and basically, as you saw, that if you want to manage GK or if you want to manage Kubernetes clusters from the command line, you need to install the kubectl utility, right? So that is just a command line utility for managing Kubernetes applications. And before you can start interacting with a GKE cluster, you have to authenticate to that cluster. So you have to run that get credentials command, right, to authenticate your Cloud Shell session. So that's what you saw me do before, right? Now, kubectl, again, you saw me do some of the gets, the describes, but basically the format has those, the command syntax has those four parts. So first of all, the kubectl, the command, the type of object you're working with, and then the name of the object and any parameters, right? So notice this is different from gcloud, because gcloud, the command or the verb is always the fourth thing, right? But in kubectl, the verb is immediately after the kubectl word itself, right? So, again, you would be expected in the exam to recognize correct kubectl commands. So understanding, not memorizing all the commands, but understanding the structure of the syntax is important. Right? So we saw some of those kubectl commands. Okay, and we also talked about the fact that we can have standard clusters and autopilot clusters. Now, with a standard cluster, we get to specify how many VMs and what the configuration of those VMs is, right? So basically here they're talking about a standard cluster, right? And so again, remember we talked about, we had the two types of clusters. And again, it's a trade-off between convenience and flexibility, right? So generally it's recommended that for beginners, they use autopilot because there's less to think about, but maybe advanced users may want some of the flexibility of standard mode clusters. Okay, so if you have an autopilot mode cluster, really all you have to do as a user of Kubernetes is provide the application container images and deploy them. You don't have to manage any of the Kubernetes cluster, right? So you see here that they've got the autopilot. With the autopilot cluster, the blue is indicating that is done by Google, right? Whereas you can see with the standard mode, Google do a little bit less because you as a customer are taking on more responsibility, right? Okay, and when you create a standard cluster, you have the option to spread your nodes across a single zone or across multiple zones across a region, right? Now, spreading them across multiple zones in a region will improve your availability because you'll be insulated from zonal failure. But if it's just a development cluster, a zonal failure might be okay, right? Sorry, I don't know what KMOH means. What does that comment mean, KMOH? I've got no idea. But as I said, the platforms supported by Kubernetes are Docker and CRIO. Both of those are supported, or the Container-O format and Docker format are both supported. Right? Okay. Okay, now we can also have what's called a private cluster. So a private cluster means that the nodes in the Kubernetes cluster do not have a public IP address, right? So if you go back and have a look at my cluster, this is a public cluster. Why is it public? Because you'll see the nodes in the cluster have a external IP address, right? Whereas if it was a private cluster, I would not have an external IP address on my cluster nodes, right? So private clusters are often desirable because you don't want your nodes of your Kubernetes cluster to be directly visible from the internet. Okay, so when you create a cluster, you can do it from the console, or you can do it from the gcloud container clusters create command, right? So notice the create is for a standard cluster. The create auto is for a autopilot cluster. Right? And again, if you okay, and again, we talked about the different types of objects in a Kubernetes cluster. So a cluster is made up of one or more node pools, and a node pool is made up of nodes, and pods run on nodes and containers run in a pod, right? So remember, your workload or your application is built with containers, but Kubernetes puts a container in a pod in order to run it, right? So a pod is a Kubernetes object, right? And again, if we go and have a look at our application, so our Kubernetes application is pretty simple. It's just a single deployment object, right? So if we go under workloads, we just have this Kubernetes object called a deployment, right? And if we click on that, we saw that we have 3 versions of the container running, right? So, and again, if we click on any of these pods, it will tell you what the name of the container image running inside the pod is. Eventually, it'll show up here. Sorry, that's taking a long time to come up. I'm not sure why. Let me just hit refresh there. Okay, so you see there's the name of the container image running in my pod, right? So again, just remember that hierarchy. Cluster is made up of nodes, workloads or deployments are made up of pods, pods run on nodes, containers run in pods, and services expose workloads, right? You can't connect to a workload from outside the cluster unless you have either a service object created or an ingress object created. Sure, you can recover pods after deleting it because you would have the configuration file, you would just recreate the file, right? So basically, if you've deleted all the pods, then you would just have to recreate the object based on the YAML file, right? So it's just like you would have to recreate the object based on the YAML file, right? Okay, so we talked about all that, I think. And as I said, remember containers run inside pods, and normally pods are associated with a workload, like a deployment, right? I mean, a deployment is not the only type of workload, but it's a very common one. Okay, so this is typically how I would define my Kubernetes objects. I would have YAML files where I would have the specification of the object in the YAML, right? So basically, when I want to create this Kubernetes object, I just issue a kubectl command, which effectively says to Kubernetes, create an object in your cluster according to this specification. So this is going to be a deployment object. It's going to have 3 replica pods, and the container image running inside the pod is the SI image latest. So these are the deployments, right? And again, we already talked about how we could create a cluster. So once we've got a cluster and we've authenticated to it with the get credentials command, then we can start creating Kubernetes objects, right? So this is if we're doing everything at the command line, right? But of course, we need this YAML file to be created. Okay, and as we said, in order to connect to our workloads, we've got to create what's called a service object. And basically that is an example of how we would create a service object at the command line level. Right? I can also do it at the console as well. Right? Okay, now I can also scale my deployment. So I can either do this dynamically or I can do it manually, right? So let's say I decided that instead of having 3 copies of Nginx running, I wanted to have 4, right? So what I could do is I could go back to the deployment object. And this is, again, I'll show you from the console, but I can do it from the command line as well, where I basically say, okay, scale, right? So I'm going to change the number of replicas from 3 to 4, right? So now when I do that, so now if I do kubectl get pods, I should see 4 of them, right? And again, you can see the new one's being created because it's got a younger age than the others. So I can manually scale or I can auto scale, right? So manual scale I can do like so, right? Or I can auto scale where the number of pods is determined by taking a metric of something like CPU utilization and then adjusting the number of pods based on the average CPU utilization across those pods, right? Okay, now if I want to remove Kubernetes objects, I can delete them. Right? Now, as long as I've got the configuration file, I can easily recreate them as well. And again, in some cases, like pods, if I delete the pod, it'll be automatically recreated, right? But for other objects like deployments, if I delete my deployment, that will not be automatically created, right? So again, if I go here and do kubectl get deployments, okay, so let's say I want to delete that one there. So delete is the verb, deployment is the object, nginx.1 is the name. Okay, so now if I do kubectl get deployments, okay, so you see that deployment has gone. And of course, if I do kubectl get pods, it's also deleted all the pods associated with that deployment. Right? Now, again, if I wanted to recreate that, I would need I could do it via the console because it's relatively simple, but normally I would just reapply the YAML file. And really, I should also delete the service because the service is no longer pointing to anything, right? So remember, I created that service object to connect to my Nginx. So again, I should really delete that because it's not pointing, because, you know, the app has been deleted. So I should delete the endpoint as well. Right? Okay. Okay, so there's a summary of the key terms for Kubernetes. The only one we didn't mention is replica sets. Replica sets is a group of identical pods, right? So basically, when I basically when I say 3 Nginx pods, they're in a replica set. 3 pods make up the replica set. Right? Okay, so let's talk about monitoring and logging. It's quite quick, but basically the monitoring and logging, it will automatically, by default, a GKE cluster will log to Google Cloud Logging, what we discussed last week, and it will also be, monitoring will also be enabled by default, right? Now, the only real configuration that you have to worry about is you can choose which logs get sent to Cloud Logging. Is there any command that you can generate the YAML file from? Well, it's not so, you can't really reverse engineer them, but you can get them, you know, you can get them. The recommended approach is to save them in configuration files and just manage them like source code, right? So that way, if you need to, you can recreate or modify them, right? So treat them as source code is generally the recommendation. Okay, so we're just going to talk briefly about node pools. So remember, node pools only apply to standard clusters, and basically all of the virtual machines in a node pool have to be identical, right? So in fact, a node pool is a managed instance group, right? So if you want to have 2 different types of machines in your Kubernetes cluster, you've got to have 2 different node pools. So that's what they're showing in the diagram, right? So imagine you had one group of virtual machines for running standard workloads, but you had another group that you wanted to run for very CPU intensive workloads. So you basically, the virtual machines in node pool B were more highly spec'd, right? So you can have multiple node pools within a cluster, right? So that's what they're showing here, right? I've got the small VM node pool is the blue nodes, and the big VM node pool is the red one. And you'll see that app 3 is running on the red node pool, and apps 1 and 2 are running on the small node pool, right? So there is a way when you submit a workload into Kubernetes, you can kind of choose which nodes you want to run on, you want your workload to run on. Now, again, I can either add new node pools to my cluster through the console or through the command line. Right? And I can even resize an existing pool if I need to add more nodes or reduce nodes for that matter, or I can even delete an entire pool. Again, they're just the CLI options. Okay, so we've already talked about a service, right? Service is an endpoint that allows communication with the pods, right? So basically, we've got different types of services for different scenarios, right? Now, the scenario that we saw before was a service of type load balancer, right? So a service of type load balancer enables somebody from outside the cluster to connect into the Kubernetes app, right? If it's not exposed, I can't connect to it from outside the cluster. Whereas things like cluster IP are services used to expose a service within a cluster. So basically one application within the cluster can communicate with another, right? And ingress is another way of being able to connect to Kubernetes applications externally. So it's similar to a service object, but it's more flexible, right? Okay, and again, we can create services at the console, at the command line, and as you saw me do, I can create them, get them, and delete them, right? Okay, now the last thing we're going to mention before the break is we also have a special type of Kubernetes workload called a stateful set, right? So a stateful set is used to implement workloads like database applications that require persistent and unique identities, right? So if I want to run a containerized version of a DBMS, for example, typically I would implement that as a stateful set, right? So here they got an example of a MongoDB database. So and MongoDB is just like a document-oriented database, but effectively to run that on Kubernetes, I need to implement the database as a stateful set. Right? So just think of a stateful set as another type of Kubernetes workload that is suited for stateful applications, right? So that way the pods have to be unique, the identities have to be persistent, and each pod has its own kind of dedicated persistent storage, right? So when we're creating a stateful set, typically we're also mounting a volume to the container in the pod, right? So if we look at this here, we've got a container image Mongo running in a pod, but it's also mounting a volume that it's going to write to, right? So just think of a volume as something that the pod wants to write to, right? So a persistent volume means that the data will be persisted beyond the life of the pod, right? So again, a stateful set, just another type of Kubernetes object that is suitable for stateful applications and typically involves volume mounts as well. Okay, and again, there's a lab recommended in your learning path for stateful sets. Okay, so I think we will break there. We'll leave the oh no, actually maybe we can finish off the horizontal and vertical auto scaling. Let me just see if there's any question here. Yes, there is a limit of how many nodes you can have in a cluster, but it's quite a high number. And again, with all these things, what I would recommend you do is, I think it's 4,000, but I'm not sure. But basically, if you just look up the name of the service